Imagine a star, a huge, blindingly bright sphere of superheated plasma, similar to our Sun, but thousands and thousands of times larger. It looks like an ordinary star. It shines like a star. It radiates heat that can be felt for light years. But this is a lie. This is a perfect cosmic disguise. If we had the technology to slice this giant sphere in half and look into its very core, we would not see a thermonuclear engine that gives life to everything. We would see death. In the very center of this object, in its heart, sits a black hole. And it is hungry. This sounds like the ravings of a madman, like a violation of all laws of nature, or the script of a cheap horror movie. We are used to thinking that a black hole is the end of a star's life. We know from school, a star lives, a star ages, a star dies, explodes, and only then, on its smoking ruins, is a black hole born. But the cruel and strange laws of physics in the early universe allowed for the existence of a monstrous hybrid, a creature that breaks every rule we know today. This is an object that devours itself from the inside. The black hole in the center greedily sucks in the star's matter, and the monstrous energy released during this deadly feeding inflates the outer layers of gas, preventing the star from collapsing completely. This is a zombie star, a cannibal star. Scientists call them quasi-stars. These are the largest, brightest, and perhaps the most terrifying objects that have ever ignited in the darkness of space. And although they are gone today, their cold, dead skeletons still rule our universe, hiding in the centers of most galaxies, including ours. In this video, we will travel to the very beginning of time, to the Dark Era, to see how these monsters were born, and try to understand what it is like to live for millions of years while an insatiable black hole grows inside you. Epoch of Monsters. To understand how nature could allow the creation of such a Frankenstein, we need to travel back in time, very far back. We are going to an era that astronomers tremblingly call the Dark Ages of the universe. This is a time about 400 million years after the Big Bang. Back then, the cosmos was a completely different place. It was much smaller, tighter, hotter, and most importantly, it was fundamentally different in its chemical composition. Today, our universe is filled with what astronomers call metals. Not just iron, but carbon, oxygen, silicon, nitrogen. These are all the elements that make up planets, asteroids, and us. They appeared thanks to many generations of stars that lived, exploded as supernovae, and scattered their insides across space, enriching it. But in the early universe, there was none of this. The cosmos was pristine, sterilely clean. It consisted almost exclusively of hydrogen and helium, the simplest gases. And this fact changed absolutely everything in the process of star formation. The fact is that modern dirty gas clouds, from which stars are born now, cool down very effectively. Heavy elements help shed excess heat, so the clouds quickly fragment, breaking into small pieces. These pieces become normal, adequate stars, similar to our Sun or, at most, 100 times larger than the Sun. But the pure hydrogen of the early universe did not know how to cool down. It held onto heat. For gravity to compress such a hot, stubborn cloud and ignite a star, this cloud had to be simply titanic, unimaginable in size. Gravity needed to gather a colossal amount of matter in one place to overcome the internal pressure of the hot gas with its mass. Therefore, the first stars in the universe, the so-called population 3, were giants. They were not born small. They were born monsters right away. But even among these giants, there were special, pathological cases. In the densest, darkest corners of the young universe, At the intersections of giant streams of dark matter, clouds of gas accumulated with a mass not of hundreds, but of millions, and sometimes tens of millions of solar masses. These clouds did not break up into star clusters. They collapsed entirely. Imagine a hydrogen cloud the size of a small galaxy, which, under its own monstrous weight, begins to rapidly fall into its own center. The gravity in this place was so extreme, and the fall of matter so fast and avalanche-like, that nature simply did not have time to hit the brakes. An ordinary star did not have time to ignite in the center of this collapse. The thermonuclear reaction simply did not have time to stop the fall. The matter there was crushed before it could begin to shine. Thus, the stage was set for the birth of an object whose scale surpasses everything we see in the sky today. Failed explosion. What was happening in the center of this collapse has no analog in the modern universe. In the usual scenario we are used to, the birth of a star is a gradual and even beautiful process. Gravity slowly compresses the gas, the temperature rises, and at some point, a thermonuclear reaction ignites. The star takes its first breath, beginning to turn hydrogen into helium. This process creates pressure that stops further compression. The star finds balance and lives like this for billions of years. But in the case of these primeval giants, balance was impossible. The mass of the falling gas was too great. The pressure in the center grew not just fast, it grew catastrophically. The core of the future star became heavier and denser every second, gaining mass faster than the thermonuclear reaction could process it. At some point, the laws of quantum physics and the resistance of materials simply gave up. The matter in the center could not withstand its own weight. Instead of igniting, the core of the protostar collapsed. It fell into itself, tearing the fabric of space-time. In an instant, not a star, but a black hole was born in the core of this cloud. Death came at the moment of birth. Usually, when a black hole is born in space, it is accompanied by the grandest firework in nature, a supernova explosion. The energy of the collapse throws the outer layers of the star into space, tearing it apart. We see a bright flash that outshines galaxies. But here, in the dense and dark nursery of the early universe, something creepy happened. The explosion tried to happen. A monstrous shock wave from the birth of the black hole rushed outward, trying to scatter the shell of the star. But the shell was too heavy. Millions of solar masses pressed down on the core. It was like trying to detonate a grenade at the bottom of the Mariana Trench or under the base of Mount Everest. The explosion simply choked. The giant mass of external gas absorbed the energy of the blow without even flinching. The supernova happened inside, but from the outside, no one would have noticed it. The black hole was trapped. It was born inside a dense cocoon of red-hot gas that wasn't going anywhere. And this gas, obeying gravity, continued to fall down, straight into its mouth. A unique, paradoxical situation arose. From the outside, it still looked like a giant cloud that was about to become a star. And inside sat an insatiable monster that began its first and last feast. It was at this moment that the engine of the quasi-star ignited. The matter falling onto the black hole heated up to incredible temperatures. Friction and gravity turned the gas into plasma, which began to emit light of such intensity that it could do what the explosion could not. A stream of radiation from the vicinity of the black hole hit the outer layers of the star from the inside and stopped their fall. Gravity pulled the gas in, and radiation from the black hole pushed it out. The star inflated like a monstrous balloon. It stabilized. It began to shine. But the source of its light was not the fusion of atoms, like in normal stars. The source of its light was its own slow death. It shone because it was being eaten from the inside. Engine on a black hole. The way this star worked violates all the principles of stellar mechanics we are used to. Let's look at our Sun. It is a giant but peaceful thermonuclear reactor. In its center, under enormous pressure, hydrogen atoms merge, turning into helium. In the process of this fusion, energy is released. This is clean, efficient, and stable energy. The Sun shines because it creates new elements. It works on creation. But the quasi-star worked on completely different, much darker fuel. It worked on gravity and falling. In physics, this process is called accretion. The gas from the inner shell of the star did not melt. It simply fell into the abyss. It spiraled into a giant funnel around the black hole, accelerating to near-light speeds. The friction between the layers of this falling gas was so monstrous that matter turned into pure plasma, heated to millions of degrees. This process is much more efficient than thermonuclear fusion. Falling matter into a black hole releases tens of times more energy than the fusion of atoms. That is why the quasi-star could maintain its existence. The black hole in the center, this insatiable parasite, tried to eat the star whole and at once. But it was too greedy. It tried to swallow more than it could fit into itself at one time. Excess energy burst out in the form of monstrous light pressure. The scariest and most paradoxical balance of forces in nature was formed. The gravity of the entire huge mass of the star tried to crush it, squeeze it into a point, and the radiation from the black hole, which was devouring this very star from the inside, pushed the layers outward, keeping them in equilibrium. Imagine this mechanism. The star lived only because it was dying. It retained its shape and radiance only because its core was continuously destroyed by the monster inside. It is like a human inside whom a huge parasite has settled. This parasite supports life in the host, heals his wounds, makes his heart beat, but does this with only one goal: to continue slowly, piece by piece, eating him from the inside. This balance of horror was surprisingly stable. A quasi-star could exist in this state for millions of years. Millions of years of continuous agony and continuous feasting. The black hole grew. Every day, every year, it bit off more and more from the star. It became more massive. Its event horizon expanded, devouring new layers of gas. And the star, in response, inflated more and more, becoming colder on the outside, but hotter on the inside. It was a perfect machine for processing matter into energy and into a black hole. And the scale of this machine defies comprehension. If an ordinary star is just a spark, then a quasi-star was a real fire on a galactic scale. Scale of madness. Now that we understand how this infernal mechanism worked, we need to try to realize the physical dimensions of this object. And this is the hardest part, because quasi-stars were so huge that next to them, even the largest modern giant stars seem like children's toys. The largest star known to us today is Stephenson 218. It is a real monster, 2,000 times larger than the Sun. But even it would be lost against the background of a quasi-star. The diameter of these ancient titans was more than 10 billion kilometers. So that your brain can somehow process this information, let's conduct a thought experiment again and place this object in our home. Imagine that we remove the Sun and put the center of a quasi-star in its place. What will happen? Mercury, Venus, and Earth will disappear instantly. We will not just be inside the star. We will be deep, hopelessly in its depths. Mars will also disappear. The asteroid belt will be swallowed. Jupiter, our giant protector, will be inside. And even Saturn with its magnificent rings will be swallowed by this wall of fire. The surface of the quasi-star would be somewhere around the orbit of Uranus or Neptune. Imagine a single star that occupies almost the entire solar system. If you flew a plane along the equator of this star, it would take you more than 1,000 years to make one full revolution. It was an object of planetary scale, inflated to the size of a star system. But even scarier was its brightness. The quasi-star was not just bright, it was blinding. One such star shone as brightly as an entire small galaxy. Imagine the light of 100 billion ordinary stars concentrated in a single ball. If such a star were hundreds of light years away from us, it would still shine in our sky brighter than the full moon, casting shadows at night. At the same time, outwardly, this monster looked deceptively calm. Due to its monstrous size, the outer shell of the star was relatively cold by cosmic standards. Its temperature was only about 4,000 degrees. This means that the quasi-star did not glow white or blue, like modern hot stars. It was dark orange or even blood red. Imagine a giant, pulsating, dirty orange ball the size of the solar system hanging in the absolute darkness of the early universe and flooding space with a dim, ominous light. It would be the most majestic and most frightening sight in the history of creation. A star that looks like a smoldering ember, but inside which rages the energy of 1,000,000 supernovae. Legacy. But nothing in this world is eternal, even such titans. This cosmic feast had an inevitable finale. The quasi-star lived only as long as it had food, as long as the huge mass of gas pressed on the black hole, feeding it and forcing it to glow. But the appetite of the monster inside grew every day, and the reserves of matter, however huge they were finite. At some point, a turning point came. The black hole became so massive, and the shell of the star became so thin that gravity could no longer hold this ball together. The balance was broken completely. The outer, cooling layers of the quasi-star simply broke away into space or fell into the abyss, dissipating in the darkness. The star disappeared. It went out, shedding its fiery mask. And at that moment, what had been growing inside all this time was revealed to the world. In the place of the giant orange ball, there remained not an ordinary black hole of stellar mass, which we are used to seeing after the death of ordinary stars. A real Leviathan remained there, a black hole with a mass of thousands, and sometimes tens of thousands, of solar masses. This was no longer a child. It was a fully formed adult monster, ready for further conquest of the universe. It was quasi-stars that gave the answer to one of the most difficult riddles of modern astronomy. Scientists could not understand for a long time where supermassive black holes came from in the early universe. They simply did not have enough time to grow by eating one star at a time. But now we know the answer. They didn't grow slowly. They were born huge right away, using quasi-stars as incubators, as cocoons in which they could safely and quickly gain monstrous weight. Today, quasi-stars no longer exist. Conditions in the universe have changed. The gas has become different, and such monsters can no longer be born. But their legacy surrounds us everywhere. Look at the center of any large galaxy. Look at the center of our Milky Way or the Andromeda Nebula. In the heart of each of them sits a supermassive black hole. These are the very parasites that survived. These are the skeletons of quasi-stars. Once, at the dawn of time, each of these gravitational monsters was the heart of a living, shining star the size of the solar system. The star died, its flesh scattered, becoming building material for you and me. But the black hole remained. It continued to grow, merging with others, until it turned into those supermassive objects that today control the rotation of entire galaxies. We owe our existence to them. Without these gravitational anchors, galaxies might not have formed. But at the same time, we must remember, in the center of our cozy, starry home, behind clouds of dust, hides an ancient, hungry predator that was born inside a suicidal star. And it is still there. Quasi-stars were terrible, but they were just the beginning. The evolution of black holes did not stop. Some of them, having gone through billions of years of mergers and acquisitions, grew to such sizes that even a quasi-star would seem like a grain of sand next to them. There is an object that is the king of all monsters, a black hole whose mass is 66 billion suns, and which is so huge that it takes light a week just to fly through its shadow. If you want to look into the face of physics' greatest nightmare, be sure to watch the video about TON 618, which will appear on your screen right now. There we talk about the abyss that looks back at us. Click before the darkness swallows us completely.